Welcome to our Chapter 9 overview for hypothesis tests. So again, hopefully you've had a chance to work through 9.2, 9.3, and 9.4, our separate sections, and this will help you look back and put everything together. So let's remind ourselves, 9.2 was when we were looking at means, was when sigma was known. 9.3 was means, sigma unknown, and 9.4 is for proportions. And then we didn't do 9.5, that was our standard deviation stuff. We didn't look at it, so I won't mention it. And what I'd like to do across the top is to sort of point out how this worksheet compares with our 5 steps that I'm hoping to get. So step 1 was the hypothesis step. So that's something I would like to see. And then the second and third columns here, the distribution and the critical values, that is what I'm calling step 2. And then the test statistic and p-value, which generally is going to come from the calculator, that's step 3. The comparison, critical value and test statistic, or p-value and alpha, that's step 4. And then the conclusion, the conclusion is step 5. So those are, I highly recommend you organizing your work that way. It's not absolutely essential, but I think it will be a good call on your part to do so. All right, so working our way through the hypothesis step. When we're working with means, there's always a null hypothesis that says the mean is equal to some number. And then the alternative is where there's variation. It says that the mean is one of less than, greater than, or simply not equal to that same number. All right. And for 9.3, it's the same because it's also about means. And then for 9.4, the only difference is that we are talking about proportions. So we've got lowercase p for proportion is equal to some number in the null. And the alternative is that same proportion is either less than, greater than, or not equal to that same number. And that's step 1. Step 2 is all about the distribution. For means sigma known, we use the standard normal, same as for confidence intervals. So standard normal we sometimes call Z. Remember, that's with our standard picture with 0 in the middle, mean of 0, standard deviation equal to 1, and we're looking at Z-scores. And then looking at the corresponding critical values in this system, then we therefore use inverse norm. And what I'll put here is that, remember, if we have that less than symbol, then we've got a left tail only. If it's a right symbol, greater than symbol, then we've got a right tail test. So alpha is only in the right tail. And if it's a not equal to symbol, then we've got a two-tailed test, and we split that alpha value, the significance level, between the two tails. All right, and then for means sigma unknown, that's our one section that we use the t-distribution. Same kind of a picture, with 0 in the middle. T-scores on the horizontal axis though, and what we have to keep in mind here is the degrees of freedom, df, is equal to n minus 1. And to get those critical values, we use inverse t or the t-table, which you'll be allowed to have with you for the exam. And that same discussion about left, right, or two-tailed, that is the same for all 3 sections. So that's depending on the alternative hypothesis in each case. Left, right, or two-tailed based on the alternative hypothesis. All right, and then back to standard normal for proportions. And hopefully all this feels familiar from confidence intervals. So back to standard normal, 0 in the middle, z-scores, mean of 0, standard deviation of 1. And so we're back to inverse norm there as well, which we all have on our calculators. All right, step 2, that is step 2, deciding how we're going to make our decision, showing where the reject zone or zones, plural, are, is or are. And then for step 3, I'm going to encourage everybody to use the calculator. So in the stat button, we'll go to the tests area. And for means sigma known, we'll use the z-test. For means sigma unknown, we'll use the t-test. And for proportions, we use 1-prop z-test. In the individual sections, you'll notice I did give you a formula for the test statistic, and you are welcome to use that. But if you have enough information to use the formula, then you have enough information to use the calculator. And it's such a time saver to use the calculator and less room for error. So I'll encourage you to do that. But if you'd like to use those formulas, they are there for you. And then for step 4, we're going to, remember for extra credit, you're going to do both of these things. You're going to compare the test statistic, which is a t or z or t value, t in this case where I'm writing, to the critical value, or value, z. And that's going to be in a picture where you draw the little distribution and show the reject zone and then put your test statistic in the picture. And then for extra credit, to do both of these, you can do one or the other though and get full credit. You're going to compare the p-value to the significance level, which is called alpha. And guess what? That is the same for all of these sections. So I don't have to keep rewriting it. Yay! And then that's the same. For the conclusion, step 5, again, kind of the same everywhere. 2 parts to it again. You're either going to reject the null specifically or fail to reject the null. You're going to say one or the other. Okay. And then make a statement about the problem. And it's a little bit tricky sometimes, but usually it's about the alternative hypothesis. Either we support the alternative hypothesis or we don't. Moving forward, it's not always going to be that way, but for this chapter it is. So first you talk about the null, reject it or fail to reject it. Then you talk about the alternative. Either you support the alternative or you fail to support it, that kind of a thing. And then guess what? Again, the same for all sections. That final conclusion is the same thing. So good things to practice. All right, and then down at the very bottom, I've got some little notes for you. So the null hypothesis always contains equality. All right, and the alternative is that less than, greater than, or not equal to. In the comparison step, we reject the null when the p-value is less than alpha. I'm going to make that red because that's the important thing. When the p-value is low, the null must go. Or when the test statistic falls into a critical tail area, the left or the right, or both, either, I should say, defined by the critical values. Otherwise, we fail to reject the null. And then there is these last little bits about the type 1 error occurs when we mistakenly reject a true null, and the type 2 error when we mistakenly fail to reject a false null. And in hindsight, it's not that much, right? It is a lot to get through, though, and a lot of reading of the problems. So you're going to do this. I would say condense this down onto a note card, and it has almost everything you need for this chapter. Take a look at what Sarah's put together for you as well, and we'll see you in 9.6, the summary chapter.